In this example, I'm going to show you how to minimize a square matrix when augmentation is required. So, as always, I'm going to write down the row and a column minimum. So, row minimum for row A, 220, and B, 420, 310, and 210. Now I'm going to subtract 220 from row 1, 420 from each element in row 2, and so on, and create a new matrix over here. Now I look at the columns, so I can do minimum from each column. So minimum from the column 1 is 20, second one is 0, 0, 0. So I'm going to subtract 20 from each element in the column 1 and create a new matrix. Now I have performed the row reduction and the column reduction, and then wrote a new table over here. I'm going to test to see if I found the optimal solution. Okay, to do that, I'm going to do just like what I did in video 1, which is to go through as many zeros as possible using a line, and then try to cross off all the numbers in the matrix using just 4 lines. Okay, so in this question, no matter which way I go, the maximum number of zeros that I can cross out in one go is 2. So I'm going to try this way. Okay, I'll try 2 this way, 2 this way, and then 2 zeros that way. Now, I still got one more line to use, but I haven't got any more zeros. So when you get into this situation, I have to do a process what we call augmentation. For the next process, look at the matrix and find the smallest uncovered number. Okay, so in this example, smallest uncovered number is number 5. I'm going to subtract number 5 from each of the uncovered element in this matrix and add number 5 to the ones that have been double crossed. Okay, so it goes like this. Right. Add 5 to the intersection, so there'll be 35 here, and the ones that's got just one line going through, you just copy those numbers. So 35, 0, 95, and 0. Over here, you got 0, 0, and 25. Second row, you got 10 and 20, so subtracting 5 from each. 5, 15, and 30. Next row, I'm just going to copy next one, 65, and 0. The bottom one, subtracting 5, so that's 10, 70, and 0. So now I'm going to try to draw lines through zeros. Okay, so if I go here, I can cross off 2. That would be 2. That would be 2. If I go there, 2. So no matter which way I go, I can only cross off 2 with one line at a time. So I shall start from here. 2 crossed off, and 2 crossed off at the bottom, and then 2. That leaves that line. So I was able to cross off all the numbers in the grid. Okay, now I'm going to find the matches. Okay, so if I look at the columns, okay, so here, column 1, okay, retailer 1 can be visited by salesman A or C. However, retailer 2 can only be visited by person A. So this is where I start. Okay, I'm going to make A go to number 2. I will just cross this off just for now so I won't get confused. Okay, so A is matched to 2. Right, so next one, let's look down the column here. So 4 can be visited by C or D, and 3 can be visited by B or D. However, here, number 1 can only be visited by C, so that's what I'll match. Okay, so C to 1. Okay, next one, let's look down again. So column number 4, if you look down this way, okay, only D can visit retailer number 4, so D will be matched to number 4. Okay, that leaves person B to go to retailer number 3. Okay, so now I can write down the matchings. Okay, so I would be doing A is going to go to retailer number 2, B will go to 3, C will go to 1, and D will go to number 4. Now remember, in your exam, you won't be crossing all these out, okay? Your examiner must be able to see the numbers and lines underneath these yellow lines. Okay, so I'm doing these yellow lines just to show you how I work out the matches. For the last part of the question asks you, what is the minimum combined mileage of all the sales representatives? So I'm going back to the original grid and then work out the final solution. Okay, so from my matching, I know A is matched to 2, and B is matched to 3, C is to 1, and D is to 4. So I'm going to add all these numbers and get the final solution of 1,185 miles. So to recap, we did row reduction and column reduction just like the first example. And because it was a 4x4 matrix, by using 4 lines, we tried to cross off all the numbers by going through maximum number of 0 each time. And we realized that we couldn't cross off all the numbers at that stage, so we had to add a process called augmentation. Okay, for that, we went back to the matrix and looked for the smallest uncovered number. So for this little example, it'll be 10. 10 is uncovered and it's the smallest. And you had to subtract that number from each of the uncovered element, and you added that number 10 to the number that's being crossed off by 2 lines, this intersection number 90. Okay, and for the numbers that's being covered by 1 line, that we didn't do anything. Okay, so when we drew up a new table, we were doing 0 and 10, and for that one we copied the 0, and that's 100 and 0, 65, and that one was 65 and 0 and 5, and then we try to use 4 lines and try to cross off all the numbers. Okay, so we only had to do 1 augmentation in this example, but sometimes you will have to do more than once to find your solution.